All right, welcome to the course, Design of Machine Elements and Systems in Agricultural and Biosystems Engineering. This course is intended for the agricultural and biosystems engineering student who has had a fair background on kinematics, of rigid bodies, from the statics and dynamics. Then also the mechanics of materials, where the materials have been considered in the design of structures or buildings and moving components. Lastly, there's also the consideration of materials of engineering, which should have already been a requirement for the mechanics of materials. But it's a separate course simultaneously taken with the mechanics of materials. Now, this course is going to be a hands-on course that would deal with the design of machine elements and systems that are intended for use in agricultural and biosystems purposes. And while we'll be first dealing with the design proper, the design theory, the design proper will commence immediately. Now, please refer to the three-dimensional rendered drawing of a wind turbine, and the drawing shows a blown up, the blown up renders of the different component parts. In view of understanding the different terminologies in machine design, the drawing can be used exhaustively. The wind turbine can be referred to as a machine itself. A machine is an apparatus using or applying mechanical power having several parts, and each part has its definite function, and together the parts perform a particular task. The components are the components of the machine are the machine elements. Organically, machine and machinery could be used interchangeably, while in some usage, machines compose machinery, and a mechanism is how this specific machine or machinery operates. And the development of such machines or elements is accomplished via machine design. Again, the discussion is on mechanisms and machines altogether. So the product you referred to is an agricultural machinery, and it's important to go deeper into the terminologies, proceeding with the term kinematics, which is the study of motions of mechanisms disregarding forces and the resulting torques. Previously, kinematics is founded, or it's built on the study of statics and dynamics. Now, dynamics is the study of motions of mechanisms now influenced by forces and the resulting torques. Synthesis, on the other hand, is a product development process, creating products based on performance requirements. And we have lastly analysis, which is the evaluation of the product configuration with due consideration of performance. Now, synthesis and analysis are working together to develop products for use, okay, for the beneficial use of of people, okay, or of the end users. Now let's go further into the terms involving machines. So you have a link, and that is a member or body, okay, joining others to form a kinematic chain. What is that kinematic chain? Now, let's go first to another uh, specific kind of link, which is the frame, and this is the fixed or stationary link, okay, in a certain mechanism. A kinematic pair, okay, or joint is a connection between links that imposes constraints on their relative movement. So, okay, a link and a kinematic pair, okay, and various links is called a kinematic chain. So joints or kinematic pairs can be lower or higher pairs. Okay, a lower pair is when two links have theoretical surface contact, okay, surface, while okay, higher pairs, okay, have point or line contacts. And then lastly, we'll talk about the specific type of kinematic chain called closed or open loop. And this refers to two or more connections, okay, that is the closed loop. And you have a single connection, which is an open loop, okay. I think that's enough for the very basic terms. There are more terms to be discussed in the next lecture video, specifically on the linkages. It's important now to proceed to the design process of machines. Okay, now creativity and inventiveness are critical, okay, in the design process, and while they are indirectly, okay, presented here, because the design process would be focused on this is the logical method of it, okay, because first you have to identify a need and then frame that problem, okay, and then there's the synthesis, okay, and then there's the analysis and optimization. Both terms, synthesis and analysis, have been defined extensively a while ago. Okay, what about optimization? Okay, now the objective of engineering is always to optimize, and that is to design, okay, while considering safety and economics. So anyone can design, okay, but okay, without due consideration of safety and economics, that is beyond engineering, okay, that is not engineering. So with optimization, okay, when we say optimal, it's the best possible conditions or settings, okay, to achieve the desired end, okay. And then lastly, you have the evaluation. Where does creativity and inventiveness come in? Okay, it's in the synthesis, okay. Now, in the machine design process, there are a lot of possible solutions, okay, when trying to solve the problem as defined in this step, okay. But okay, from among those designs, okay, that would include creative insights or inputs, okay, there has to be a means to determine which would best solve the problem, okay. Now, it's important to identify, to state here, okay, at the onset that, okay, synthesis is the process of concept generation, okay, of how to solve for the problem identified. But okay, if ever okay, there's a need to go back, okay, there is a way to always go back to the previous um, step, okay, and this is what is called iteration. But before we go to the full iterative process, or that is the machine design process, okay, let's first um, go to the next step, okay, which is analysis and optimization. Now, again, there has to be, well, a definite solution, okay. They're not the only solution, but when we say analysis and optimization, there's the need for a definite ideal, okay, no, realistic, sorry, a realistic optimal solution, okay, to the problem. And that's accomplished using the steps of engineering computations and simulations, okay, if that is available, okay. Now, performance can be achieved via various means, case sensitivity analysis, and scenario analysis, multi-criteria decision analysis, uh, but the performance has to be ranked, and the first, okay, should be assume the best possible solution. Simulations allows for the solutions, okay, to be um, um, determined without um, actual fabrication or manufacturing of parts, and this is where it becomes very advantageous to learn of uh, numerical methods of solutions. Okay. Now, last is the evaluation. Okay, you have to have performance tests conducted on the design to determine the performance, the efficiency and effectivity of that specific design. Again, each step can be, okay, returned to its previous one, and thus it is what is called iterative and uh, in concept. Okay, so each of these, okay, could be returned to a previous step. Okay, apologies for the hours, but this basically just means that all the steps, okay, could be iterated. Okay, so this is a fully iterative process. Now, in the creativity and idea development, okay, it's best, it's probably best to give an example. In most, okay, in most engineering courses nowadays, okay, um, the idea is to go towards project-based learning, or for the students to synthesize a project. Okay, it could be a product or a service that is based on the engineering, on a specific engineering discipline or disciplines. And this is actually the formulation of technology startups, which is a way to introduce a new technology to the society, okay, that is that has not yet been there, okay, previously. That's why it's a technology startup. Now, the concept of this is based on the idea that engineering is art and practice together, and that I've hinted on it a while ago, that it should be for the beneficial use of people. Okay, this is from Chris Weiss of a British company called Expedition Engineering Limited. All right, it's I think uh, wise to look into the paradigm of the machine design process via a technology startup, okay, design, okay, or a product, okay, called um, physics, okay, and in here, okay, it's necessary to see the pain points. Okay, when you see pain points, this is there's a need. Okay, there's a problem. So people would have problems, and then comes a need. Okay, and what's the need here? Okay? Or what's the problem? Initially, it's the awful beer taste. Okay, and the need is for what? Flavorful beer, and the solution is what? To improve the dispensing of beer. And this is where, okay, the product physics draft pour, okay, you can go to the link www.physics.com to look up the product and see what it has to offer. But I'll be delving into um, the solution, okay, solution that the product offers, and also how it works, okay, because it has already been it's patented, and so it has been disclosed to the public. Okay, and this now leads to satisfaction. So that for the solution, okay, there's the reduction of absorbed um, carbon dioxide in the carbonated beverage. And then, okay, there's the reduction of the absorbed, um, sorry, I think it's redundant, but eventually, okay, uh, the oscillating motion, okay, should produce, okay, sonic waves to efficiently mix this carbon dioxide with the beer to form the froth at the top. And that, okay, involves better flavor in the beer. Now, this is how did the inventors get to this stage of development? Okay, that has to do with a lot of research and development. Okay? So the synthesis is the synthesis part, the synthesis analysis and optimization part is hidden in between this need and solution. Okay. Now, it has been said, okay, that um, in the synthesis, okay, certain criteria has to be considered, and here are various design considerations and criteria that an engineer can make use of to determine the actual, okay, the actual or the best or the optimal solution. There's functionality, what is its purpose, utility, is it useful in the practical sense, there's reliability, the question is if it's dependable, okay, during actual use. And then there's strength, is it structurally strong, okay, there's stiffness, while metals are strong, they can be still workable. Okay? They can be worked on. Okay, and stiffness is the resistance to bending due to unapplied force. Where is the measure of the ability to resist action of loading, such as a force repeatedly introduced? And then there's corrosion, a chemical property uh, identifying the resistance to chemical reaction. Okay, to a corrosive chemical. And there's also thermal properties, okay, covering specific heat, um, thermal conductivity, and others. There's surface finish, okay, relating to the gloss or the shine of the material surface. And there are other, okay, properties. Some relate to the physical, others to aesthetics and durability, even the environmental, because that is a United Nations okay, goal. Okay. Now, these design considerations should be taken into um, consideration, okay, when designing machines, mechanisms, and machinery. Some of the criteria may be neglected, to depend on the requirements of the end user. Okay, and again, engineering is altering and using the physical world to create change. I'm seeing you in the next lecture. I believe it's uh, time to go directly to the design process. Thank you for listening, and I'll see you then.